All right, so now that we have figured out how to identify corresponding sides and angles, we're actually now going to use that information to find a missing side length if we have similar figures. So you'll notice here for the first example that we've got a rectangle ABCD, and it looks like it gets a little bit larger over here when it becomes rectangle EHGF. I know to read them in that order because I can identify these corresponding angles. If I move this right here, and then I just kind of tilt it sideways, and then just kind of enlarge the rectangle. My rectangle's, there we go, this is what I need it to be. There we go. So you can see here that A is now E, and then H was over here for B, G, and C, and F. So we can fill that part in here now that A and E went together, B and H, C was down here with G, and D was over here with F. All right, so then we can see AB, A to B matches with E to H. We've got BC, so BC would be this side, that matches with HG. So this is again the part from the last video, just knowing how to match these up. So C to D down here would be G to F over here. So we got G to F. And then I think you guys know that if I went from D up to A, which is the missing side here, that it correlates over here with the F to E, so FE. So the idea, like I mentioned, is that we can now say ABCD is similar to EHGF, which is what I have right here. And the similarity statement that I just said, I can show it in the language of algebra here. ABCD is similar to EHGF. In the previous video, this was already here for you, and you used it to identify the matching sides. So today we kind of went backwards. We saw the picture and filled it in to write the similarity statement. Now, the main point of today's video is to just use this background knowledge to know how to find a missing side if you have proportional similar figures. Now, we just said a second ago that this side, and I'm going to highlight now, the unknown side right here matches this side right here. So whatever it started out as, it's now 15 over here. Now the top part started out as a 26, and it got a little bit larger and is now a 39. So we're going to use a proportion to solve for this unknown side. And the proportion that we're going to start with here is that the corresponding side here, this unknown, matched with here. So we're going to say that our X, our unknown, matches with a 15. That's green to green. And then over here on this shape, the 26 matched up with a 39. So we're kind of combining a couple units here now. This is a proportion. And we're combining that here with our knowledge of corresponding angles and sides. At this point, we can simply cross multiply and divide. We can use our calculator to multiply the 26 times the 15, and then we'll divide that by a 39. So we've got a 26 times 15. That's 390. And when I divide it by a 39, we get 10. So the length of the unknown side would be 10. Okay, so we just found that as a 10. Now to prove it, we've got some proportions that can prove the figures are similar. So an example, this side AD, see how I have it in green? It matches up with EF right here in green. And then if I say AB, it matches up with EH. So the numbers that we're saying now, we just found side AD to be a 10. And it matched up with EF, which is the 15. And then we're saying that the blue sides, the 26 matches up with the 39. So you might see, y'all, you might see proportions proving it. You might see it over here with letters. And you know that this proves it because you can see, again, I'll highlight it. We've got the green side matched with the green side. And then the blue side AB up here matched with the blue side EH. So that's true. The green matched with the green and the blue matched with the blue. And then if you saw numbers in its place, you guys know the ways that you can prove that this is a true statement is that if you just, again, multiply this times this, it was a 390. When we multiply 10 times 39, it's a 390. And because those are equal, we know those are proportional. So therefore, yes, these figures are similar. All right. So here we've just, again, started with a rectangle. Here now we're going to see a parallelogram. And again, when we're just looking at identifying corresponding angles, you guys can see here that A matches up in this spot R. Luckily, these shapes are kind of oriented the same way. Nothing's like been kind of turned like how it was turned this way. So A and R go together, and then B with U, C down here with T, and then it looks like over here S and angle D. So D corresponds to S. So then we can see AB up here goes with RU, and BC this side is UT. CD down here would be TS. And DA on this side matches with SR. So we've got our corresponding sides now. And since we have our angles and sides matched up, we can use that to write the similarity statement. Again, A goes with R, so A should be in the same spot as R. B went with U, so B is in the same spot as U. C went with T, so we can see that those correspond. And D here with S. So we have our similarity statement that ABCD is similar to RUTS. Now we want to try to find side Y, and side Y is up here. So we can say that this side, our unknown, matches with the 12. I've got those there in red. And then in purple, I can show that the 30 matches up with the 15. So when we're setting up our proportion, again, we're trying to show that purple goes with purple. So we've got the given ratio that the 30 shrunk down to a 15. And then we can use that to say, okay, the Y shrinks down to a 12. Now that right there might already be enough for you guys to figure it out. If this 30 gets cut in half to be a 15, then this must have been a 24 to get cut in half to be a 12. So when you think of it that way, it's very simple. And you can kind of see right here, the 30 gets cut in half to be the 15. So we know that the 24 has to be cut in half to be a 12. Of course, you can always cross multiply. We've got a 30 times a 12. I'll just show that because I know a lot of you like to just go with one method that works every time. So that's a 360. And when I divide by the 15 here, see how I get the 24? So we know that the unknown side length here is a 24. This would be a 24 up here. And again, to kind of prove that it's similar, let's check this side out. If we go from D up to A, that would be the 30. And now this one, take a look at what this does. This says from D to A, and then A to B. So it goes like this on the shape. So we want to see if D to A, then A to B. Let's see if the next fraction does that with the letters. See how it says SR? So we're going from S to R, and then R to U. So let's see if we put some numbers in if this holds up, and it should, because it's saying the side matched with the top should be proportional with this side matched with the top. Now up above, I want to point out that this one didn't do side matched with top. This one went green to green and blue to blue. This one is showing that if you go side to top and side to top, that it should also work. So here, DA, this was a 30 over a 24. And then this side is a 15 over a 12. And again, I think a lot of you will see that this is going to be a true proportion because we can now look at it this way. This gets cut in half and this gets cut in half. So yes, this is going to work out. So you can really set your proportion up that way too. You could put a 30 over a Y. I'll show you guys. This is another way to set it up. You could put the 30 over the Y and then the 15 over the 12. And when you cross multiply, when you do 12 times 30, that's 360. And then when I divide it here by that 15, I'm going to get the same answer. I'm going to get the 24. So there's lots of proportions that can prove that these figures are similar. And as your math teacher, I'm going to actually recommend this method up here, that you go from corresponding side to corresponding side, and then over here and match up the corresponding sides. And right here is a good example of why this is going to be our strategy. Let's go ahead and flip over now. You guys should flip over and be looking at this example with me. And when you guys look at this triangle now we're looking at some three-sided stuff. Do you see how we have two missing sides over here? So we're going to need to find X and Y. Now, when I look at this, if I see these sides, I think that you guys would agree that the 12 is the longer side between 12 and X. So if I'm trying to match up the longer side here with the 12, this side right here is the longest side and it's going to match up right here. So that means this side matches up here. And then down here in green, I can show this side matches up with this side. So if I follow the red, if I'm going from A down to C, it's the same as me going from K down to M, okay? So we can see that A and K go together, and then I'll use purple. I'll say C down here matches up with the M, and then over here, L, if you go from K down to L, that's A down to B. So I just kind of color coded. You can kind of see that the shape looks like it's been flipped, and then it looks like we enlarged it a little bit to make this shape over here. So we said that A went with K. We said that B in blue went with L, and that C in purple went with M. And that right there is my similarity statement. ABC is similar to KLM. We said that side, let's see, AB was in blue right here, so A to B corresponds to KL. AC was the one in red, so A down to C is K down to M. And BC, we said B down to C in green, so L down to M. And with that last one, I'll just remind you guys that BC, see how it's right here? It's the last two, so LM is the last two right here, so that's how that similarity statement works. Now we're going to try to solve for sides X and Y. And you might remember that when setting up a proportion, it's a good idea to look for the given ratio. The given ratio here is that the 12 turned into a 30. And we're going to use that to find the blue side. If the 12 turned into a 30, we want to see that this X turned into a 15. We're also going to use that given ratio of the 12 and the 30 to say, okay, this Y turned into a 25. So we've got our two proportions. Now this one I can kind of see right here, this times 2 relationship, or if you look at it backwards, it gets cut in half. So the 12 gets cut in half right here to be a 6. So we know this one is a 6. I just found that one out pretty quickly. That's a 6. Okay. Now this one, I don't see anything that I can quickly do for the 12 and the 30 or the 30 and the 25. So let's bust out the calculator and just cross multiply here. We got 12 times 25. All right, cool. And now let's divide that by the 30, and we're going to get a 10. So the Y over here is a 10. So Y was 10. Put that answer down here. And over here, we said that it was a 6. So that's how we can use our knowledge of the corresponding sides and how to set the given ratio up to then make a proportion. And you've got X turned into the 15, and then the Y turned into the 25. All right, and last but not least here in your notes, we have another shape where we can see the triangle is embedded within the other triangle. We saw one like this earlier when you guys took notes, and it was down here with example 5, the triangle within a triangle. So a similar strategy, you can take the two triangles and kind of redraw them if you want, and I'll do that down here for you. I can take the bigger one and the smaller one and put them side by side and relabel it. You don't have to if you don't need to, but I just kind of wanted to show you that that's how that one works. And you can see again, if I took this one right here, the smaller one, if I just take it and click it and drag it, you can see that that's how it becomes the larger one, but I'm going to move it down back to how it was for right here. Now I think I'll leave the other one, that smaller one, separated just so we can see that in that smaller one, this was labeled G. This was labeled F. They share that corner. And down here, the right angle was labeled E. So the top corner G matches up with this top corner C. So C and G. F and F are the same thing. And then D, this right angle corresponds to this right angle E, which is again where I get my similarity statement here. CFD matches with GFE. I can use that to say, so DC, so D to C would be E to G. So CF would be GF. And DF, which is D to F, would be E to F. Now the unknown side Q here, this side, let me highlight it. We'll put it in green. The unknown corresponds to this right here. That's going to be something that we can use. And the 4 was enlarged all the way to be the 8. So if the 4 doubled to become an 8, then the 3 doubles to become a 6. If you feel like you can see the answer without even needing the proportion using just the shapes, you can always rely on that. But again, the thing that I just said was that the way I just showed it actually was the 4 turned into an 8. So I went the 4, the smaller 4 turned into the blue 8, the bigger 8. So then the smaller 3 turned into the Q. And that's just kind of how I was able to see, well, this got twice as big. So this should get twice as big and be a 6. We could say Q and 3 match up. So the Q matches up with a 3. So the big to small. So then 8 down to 4. And once again, you can kind of see, here's my times 2. So here's my times 2. Now, real quick, before I stop this video, you are going to turn over and practice on your own. But I want to mention 2 quick things. When you're doing number 3, when you solve for M, you are doing everything right if you get a repeating decimal. So I just want you to round that to the nearest tenth. You're doing everything right if you get a repeating decimal. So remember, if you see something that ends in like a 0.666 and that repeats, then that would just be a 0.7. If you saw something that ended in like a 0.333 and that's what repeated, since this is not a 5, it would just stay a 0.3 if you rounded to the nearest tenth. So your answer to this question is going to be rounded to the nearest tenth. I just wanted to point that out. And I'm going to erase that now so nobody takes notes. And then down here, there is a typo. The 6, you guys see the 6 down here. I want you to scratch it out. I want you to scratch it out. The 6 should be right here. There should be a 6 right here. Scratch it out if you see one right here in your notes, okay? So in your packet, there should not be a number down here. You have this matches up with this, and then you're going to use that for the blue matching up with the blue. There will be a Google form for page 6, and that concludes this video. Thank you for watching.